See, Unit 3 in computer architecture is processor and control unit. In this unit, we are going to learn about MIPS architecture, pipelining concepts, and hazards. Basic MIPS implementation. MIPS is million instruction per seconds. Instruction set is divided into three classes. The classes are memory reference, arithmetic, and logical branch instructions. So these instructions are going to be executed with the help of MIPS architecture. MIPS instruction executions are: it first fetches the instruction from the memory. After it read the register while decoding the instruction. The format of MIPS instruction allows the reading as well as decoding to occur in simultaneous way. After fetching of instruction, it is going to the execution phase. Finally, it performing a calculation and the result are stored into the registers. So this is MIPS architecture implementation. It is having a component like program counter PC, instruction memory, instruction register, a data memory, and control units. It having additional one more unit, the control unit. The control unit is added or connected with every part of MIPS architecture. First, it fetches the instruction from the program counter. After it perform instruction execution based on the addressing provided by the instruction memory. It will perform arithmetic operations with the help of the adder. It may fetches the opcodes from the instruction memory or else the register memory. It will performing a ALU operation. Final one is a write back. It will write the results in a data memory. Building a data path. The elements that process the data and addresses in a CPU, memories, a register, program counter, ALU, and adder. So these are all data path connectivity. The architecture is divided into a two-part: instruction memory and the register along with the ALU. The data path for different instructions. The data path can be established for arithmetic and logical instruction, load and store instruction, branch instruction, and single path. Data path for arithmetic instruction, in a sense, it will perform all the arithmetic in operations with the help of the register memory, followed by the ALUs. Load and store operations, it will load a data into a memory and store the contents from the memory. Data path for a branch instruction, while it will execute a branching instruction, it check whether the branch conditions are equal or not equal. That is also be performed with the help of the adders and the multiplexers concepts of MIPS architecture. Creating a single path. So in this architecture, it is possible to creating a single path. To execute an instruction, at least one clock cycle is required. Within a given clock cycle, one instructions are being executed. So that is also using the same MIPS operation, the slight modifications of one more component, shifting left by 2 bits. Control implementation scheme. Designing the main control unit. The operations of data path are R-type instruction, load and word instruction, branch on equal instructions. These are all the ALU control lines. So based on the line, the functions are being performed. It will perform add operation or and, subtract or set to less than or nor operations. Designing of the main control units or type load and store branch instructions are being represented with the help of this headering format, starting with the 0 after the source registers, destination register, shift among them, and the functions. So these are all the red arrow marks which represented the data path between the different blocks of the computer. Next one is a pipeline. The pipeline is an implementation technique in which multiple instructions are overlapped in executions, used to increase the speed and performing the operations. With the help of this pipelining concept, there are 2 stages of pipeline. One is 4 stages pipeline, another one is 6 stages pipeline. The 4 stages pipeline, which include instruction fetch, instruction decode, execute, and write back. It will simultaneously execute 5 instructions in a single clock cycle with the help of the pipelining concepts. Six stages in the sense. The first one is instruction fetch, decoding the instruction. After one, calculate the opcode, fetching the opcode, execute the instruction. Final one is write the operand. So these are all the instruction execution timelining diagram. It will continuously executing 9 instructions for a given clock cycle. The pipeline stages are fetching the instruction, decoding, executing an instruction, accessing an operand. Final one is write back the result. While the multiple instructions are executed in a parallel way, the hazard problem may occur. Hazard is a condition that prevent an instruction in a pipeline for executing its next scheduled pipeline stage. Any reason that causes the pipeline to stall is called a hazard. The types of hazards are structural hazards, data hazards, control hazards. Control hazards in the sense, while you are executing a branch instruction, the control hazard problem may occur. So you needed to check whether the branch is equal or not equal. So while you are executing that kind of instruction in a pipeline way, this hazard problem may occur. Then the branch penalty in the sense, time lost due to the branch instruction is known as a branch penalty. The pipeline performance are being evaluated with the help of the clock cycle as well as time needed to execute a given set of instructions. That can be evaluated using the efficiency formula EM equal to N divided by M plus N minus 1. The pipeline data path and control. For every data path connection, one of the control units is additionally added to monitor if the blocks are working in an effective way. The 4 stages of instruction pipelines are instruction fetch, opcode loading, execution, and opcode store. So this is organization of CPU for a 4-stage pipelining instruction. So these are executed in a simultaneously way. It have a 2 catch instruction and then a 2 memory instructions. So both the instructions are parallelly executed with the help of the pipelining concepts. Similarly, the MIPS architecture is also implemented with the help of the pipelining concepts. So the architecture is divided into these parts: the instruction fetch, decode, execute, and memory access. The blue line which indicated the partitions or implementation of our pipeline concepts. Thank you.